Good morning, everyone. Today we are going to show you what happened behind the scene and how our kingdom managed the production of desalinated water. Marhaban bikum.
Imagine a country where rain is so rare that entire regions go years without seeing a meaningful storm. No lakes, no rivers, almost no natural fresh water. It's also the birthplace of Islam. Now imagine that same country supporting tens of millions of people, megacities like Riyadh or Jeddah, heavy industry and modern agriculture. Every glass of water, every shower, every factory and hospital. None of it should be possible here. Yet it is.
The Kingdom of Saudi Arabia is one of the driest places on earth. Almost no rivers, almost no rainfall. Yet millions of people depend on water every single day.
Welcome to Industrial Horizon, where we break down the megaprojects and engineering systems that quietly keep the modern world running. Today, we're inside one of the most extreme infrastructure systems ever built, Saudi Arabia's nationwide desalination and water pipeline network, a machine designed to pull the sea out of the ocean and push it hundreds of kilometers into the desert. And if you enjoy deep dives into megaprojects and modern engineering, subscribe now. The core problem: a country without water. Saudi Arabia covers more than 2 million square kilometers, yet over 95% of its land is desert. Average annual rainfall is below 100 millimeters, while summer temperatures routinely exceed 45 degrees Celsius. There are no major rivers, no renewable surface water sources, no natural freshwater reserves to scale with population. Oil made Saudi Arabia wealthy, but oil cannot sustain human life. Saudi Vision 2030 is a strategic framework launched in 2016 by Crown Prince Mohammed bin Salman to reduce Saudi Arabia's dependence on oil, diversify its economy, and modernize society. From an engineering perspective, the problem was clear: either limit growth or engineer water into existence.
To survive here, water cannot be found. It must be engineered at a scale few countries on earth have ever attempted.
Saudi Arabia chose the second option. System overview: moving water at national scale. Saudi Arabia's solution is not a single plant or pipeline. It's a nationwide system composed of coastal desalination complexes, high-capacity pumping stations, thousands of kilometers of steel pipelines, redundant monitoring and control infrastructure. This system operates continuously. Unlike oil or gas pipelines, water pipelines cannot shut down. Demand is constant, pressure must be stable, and failure is unacceptable. From an engineering standpoint, this isn't just water delivery. It's critical national infrastructure.
This is not a local system. It is a national water network. Thousands of kilometers of steel delivering life across the desert.
Why the sea became the water source. With no rivers to draw from, Saudi Arabia turned to the only resource it has in abundance: seawater. The Red Sea provides a virtually unlimited supply, but seawater is chemically aggressive and unusable without treatment. At roughly 3.5% salt content, seawater destroys crops, corrodes infrastructure, is unsafe for human consumption. Desalination solves this, but at scale, it introduces a new challenge. Desalination is not primarily a water problem. It's an energy problem. Desalination equals energy management. Reverse osmosis. Desalination requires extreme pressure. To separate salt from water at the molecular level, pumps must generate pressures approaching 60 bar, roughly 60 times atmospheric pressure. These plants operate 24 hours a day, consuming massive amounts of electricity. At national scale, engineers aren't just producing water. They're balancing grid stability, energy cost, and continuous output. In many cases, desalination plants are paired with dedicated power generation to prevent destabilizing the broader electrical system. In megaproject engineering, water and energy are never separate systems. They are tightly coupled machines.
Here, seawater is pushed through membranes under extreme pressure. Salt is left behind. Fresh water continues forward.
From ocean to plant, intake engineering. The process begins offshore. Large intake pipelines draw seawater from hundreds of meters out at sea, where temperature and sediment levels are more stable. Before entering the plant, water passes through coarse screens to block debris and marine life, fine filtration systems to remove suspended solids. This protects downstream equipment and membranes from damage. At this stage, the goal isn't purity, it's system protection. Every step reduces wear, extends lifespan, and stabilizes long-term operation. Reverse osmosis, separating salt from water. After pre-treatment, seawater enters reverse osmosis. High-pressure centrifugal pumps force water through ultrafine membranes that allow water molecules to pass while rejecting salt ions. This process happens in stages. The first stage removes the majority of dissolved salts. The second stage strips out remaining trace ions, producing near-pure water. From an engineering standpoint, reverse osmosis is a trade-off. Extremely effective, extremely energy-intensive, highly sensitive to contamination, which is why upstream filtration and precise control are critical.
This system never stops. Pressure, flow, and safety are monitored every second. Water here is not passive. It is controlled.
Building pipelines for extreme conditions. Once desalinated, water must be transported inland. This requires pipelines designed for constant internal pressure, extreme temperature cycles, long-term structural stability. The pipes are manufactured from high-strength carbon steel, similar to oil and gas pipelines. Each section, nearly 2 meters in diameter. Walls up to 25 millimeters thick. Weighs several tons. Every weld is inspected using ultrasonic testing. Every surface is coated to resist corrosion. Because once buried and pressurized, failure is not an option. Installation logic. Why pipelines are buried. Pipelines are installed underground, not for appearance, but for performance. Stabilizes temperature. Protects coatings from UV degradation. Reduces thermal expansion stress. Shields infrastructure from surface activity. Survey teams map routes using GPS and terrain data to avoid unstable soils and erosion zones. In rocky regions, controlled blasting is used to carve precise trenches. Before placement, a sand bedding layer distributes load evenly along the pipe. Side boom tractors then lower pipe sections with millimeter precision. In extreme environments, exposure is weakness. Burial is protection.
One failure could affect millions. That's why every kilometer is inspected, protected, and engineered for reliability.
At this scale, reliability always beats efficiency. The system is built with parallel pipelines, backup pumping stations, continuous pressure and flow monitoring. Sensors detect minute changes that could indicate leaks, fatigue, or ground movement. Maintenance teams are positioned to respond rapidly, even in remote desert locations. Because in a system like this, failure doesn't mean inconvenience. It means millions of people without water. After desalination, water is too pure for human consumption. Minerals like calcium and magnesium are added back to improve taste, balance pH, protect downstream infrastructure. Only then is the water released into the national distribution network, flowing towards cities, industry, and agriculture deep inland. What reaches the tap is the final output of a massive industrial process.
When water reaches the city, it disappears from sight. Life continues. The system becomes invisible.
Desalinated water in Saudi Arabia can cost around $5 per cubic meter, far higher than natural freshwater sources. But without it, cities would not exist. Industry would halt. Modern life would collapse. This system doesn't defeat the desert. It out-engineers it. If you're fascinated by the systems that make modern civilization possible, you're exactly where you should be.
If you enjoyed this documentary, welcome to Saudi Arabia, and don't forget, Al-Ma'u huwa al-Hayat. It means water is life. Thank you. If you enjoyed this